I say, tally-ho! Well, it's simply marvellous to see you. Absolutely frightfully wonderful. A lot of people have been asking me, when are we going to look at what the periodic table actually means? Isn't that chemistry? Yes, it is. And you know that we've been doing quite a lot on the development of the periodic table and what people didn't know before the periodic table was formulated. But surely now we do know. Shouldn't we do that? Of course we should. You're quite right. And so I'll abandon this accent because it's annoying, and we'll get to how we represent the elements on a table like this. The first thing you'll notice is that most periodic tables look like this, with a massive load of 10 columns in between here. We've simplified it. This is just for the first 20 elements. Once we know what happens with the first 20 elements, we can extend that to what happens with the other 100 plus elements. So let's have a look now. We've got a number in each compartment here, in each little rectangle, and it just goes from 1 to 20, because we're only looking at the first 20 elements. And that's the atomic number. Now, that's how the periodic table is arranged, in order of atomic number. And of course, Mendeleev didn't know this. He had no idea what the atomic number was, because he had no idea what a proton was. And the atomic number is simply the number of protons. Pro, that first part of the name, the prefix, indicates that it is positive. And as you probably know, protons are the positively charged subatomic particles in the nucleus of any atom. And the definition of that atom is how many it has. So number 17, any atom with 17 protons in it is chlorine. Any atom with, say, I don't know, what are we up to here? Fluorine. Let's keep those ones. With 9 protons is fluorine. And these are in the same group, because a column in here is a group. Now, I'm only going to refer to 1, 2, 3, blah, 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 7, 8 groups. On your periodic table, you've got 18 groups. But just in this presentation, I'm going to refer to them from 1 to 8. And there's a reason behind that, and that reason is electrons. Before I get to the electrons, we knew that a column is called a group because that was decided many, many decades ago, and it's just reasonable to keep the same terminology. A row is called a period. When we look across this period, we notice something, that this one, period 2, has 8 elements in it. This one, period 3, has 8 elements in it. It's like the octave rule. It's what you'd expect. But period 1 has 1, 2 in it. And it doesn't make sense. But let's have a look why they're arranged this way. Of course, there's only 2 in this one, but it goes on. There are many elements in period 3. So let's have a look what we're going to do now. Hydrogen. Every hydrogen atom has 1 proton in its nucleus. Every helium atom has 2. Every lithium atom has 3. Beryllium atoms all have 4, etc. We'll go along with this and work out how many each have. But let's go to electrons. Let's get to the basis of chemistry. Now, the charge, the net charge of an atom is 0. Now we know a proton has a positive charge. We also know that an electron has a negative charge. An electron is negative, proton is positive. A neutron, of course, is neutral, and we're not considering that in this video. But yeah, what we're going to look at is because every atom has a net charge of 0, it must have the same number of protons, positive, as it does electrons, negative. So, an atom of hydrogen has 1 proton in the middle, in the nucleus, and 1 electron. There it is. That's supposed to be a negative charge, but it joined up there. Good. And we're going to draw all of these and see what pattern we make. Helium has 2 protons because its atomic number is 2, and it's got 2 electrons. And I'll stop drawing the charge on the electron because it's going to end up being too much by the time I get to 20. And that's all very nice. Lithium, though, lithium 3 plus, now we go to period 2. If it's period 2, that means it has 2 circles here. These circles are called energy levels. Sometimes they're called shells. It depends on whose terminology you use and usually how old you are. I use energy levels. And here's lithium. It's got the same 2 as helium had, and it's got 1 more on this outer energy level. The outer energy level is what's most important. And I'm going to stop here and draw the rest, and then start another video.